Good morning and good afternoon. My name is Penise Palvanloo, and I'm one of Canada's representatives to the Mission Innovation Integrated Biorefineries Mission. Along with my other Canadian colleagues, I represent the Canadian Forest Service, which is within Natural Resources Canada, which is part of the Government of Canada. Within the Integrated Biorefineries Mission, we are joined today by representatives from the Netherlands, so Kees Kwans and Gijs Mulder, and Switzerland. And Joanna Trudeau is here with us today. And Dominic Notier is also one of the Switzerland representatives. I would like to begin by acknowledging that I am joining you today from the traditional and unceded lands of the Anishinaabe Algonquin Nation, who have stewarded this land since time immemorial. On this land we call Canada, September marks an important month to reflect on the lasting harm of Canada's residential school system on many First Nations, Inuit, and Métis families. I welcome you to take a moment to reflect on your relationship with the lands from which you join us today. It is my pleasure today to welcome you all to our virtual mini-conference on an important class of biomass-based plastics, polyhydroxyalkanoates, or PHAs. This event is hosted by the Integrated Biorefineries Mission, which aims to develop and demonstrate innovative solutions to accelerate the commercialization of integrated biorefineries. The Netherlands and India are currently the co-leads of the mission, with Canada, Switzerland, and Brazil as core members, and the UK and the European Commission as the mission support group. Our PHA mini-conference falls under Action 2 of the Integrated Biorefineries Mission that aims to advance collaborative research on new biomass-based fuels, chemicals, and materials. We hope that today's event will be a helpful catalyst in advancing international collaboration on PHA scale-up and commercialization. So before I begin, I'll do a few housekeeping items, just to keep us started and keep us track throughout today's event. First, please check to make sure that your microphones are off. If needed, my colleagues will mute participants just to make sure that we're minimizing background noise throughout the event. We encourage you to keep your video on during your presentation, as well as during the discussion portion. If you experience any technical issues today, please let us know in the chat, and we'll do our best to help you. With that being said, we'd like to minimize the use of the chat today to technical issues. We're hoping that this will help us focus on the presentations, and please keep all of your questions and your reactions so that we have a lively discussion during the discussion period. As I stated, we'll be recording the presentation portion of today's mini-conference, and we will make this recording publicly available, as well as a final report after the event. So now, with that being said, I'd like to welcome Rick Passanier to set the stage for the rest of our presentations by providing an introduction and overview to PHAs. Rick is a program director at Biobased Circular, a fund backed by the Dutch National Growth Fund. He is also a founder and board member of GoPHA, a nonprofit initiative to accelerate the adoption of PHAs globally, and a co-organizer of the 4th PHA World Congress hybrid event that took place in Dusseldorf, Germany from September 2nd to 4th. Rick, over to you.
Yeah, thank you, Penise. It's nice that you pronounce my last name in some sort of a French way. That doesn't happen too often, but it's nice to hear it. Actually, my last name is pronounced Passanier in a very Dutch and direct way. So my full name is Rick Passanier. I'm very happy to be here, and just to give you all a brief overview of the PHA landscape. And I'm going to share my screen. I hope it's visible and also in the right format. If not, please let me know.
You're good.
Okay, perfect. So GoPHA is a foundation established in 2019 with a mission to drive adoption for PHAs globally. And since 2024...
Rick, sorry, I'm just gonna pause you for a second. Is it possible to speak a little bit louder?
Yes, I can also close, be a little bit closer to the mic. Is this helpful, or?
I can hear you, but it is a little bit quiet. Joao, are you able to hear now?
No, I only hear you.
Okay. How about now? Are there other people with problems?
Yeah, that's very good.
Let's go ahead. Yeah, I just try to speak as close to the microphone as possible.
Okay, so here we go. And since 2024, I'm also involved as a program director at Biobased Circular, which is a subsidy fund based in the Netherlands to stimulate growth and industrialization of bio-based polyester materials, including PHA as well. And Go PHA, of course, since the establishment in 2019, has seen a lot of the development of the industry. And we are very happy that we have a very lively community of producers and also converters, knowledge institutes, and brand owners to join our education work, but also our joint voice towards policymakers all around the world, not only in Europe, but also in the USA and in Asia as well. I'm going to skip through a few slides, but I keep them in the deck because I just want to make sure that you get them after this meeting. A lot is on plastic pollution and microplastics, and also some of the background of PHA. I'll just skip through that. I just want to highlight the innovation waves within PHA. So we have identified 3 waves of innovation, which we specify as the very early inception of working with PHA, which was mainly focused on trying to get and characterize individual PHA molecules, doing extraction basics, still a lot based on solvent recovery, and also fermentation, which was mainly a translation from the lab facility, which was not that scalable at that moment. Then we have the first wave of industrialization, as we call it, until a few years ago with scaling up trials, but also some failures in that sense from early innovators like P&G, like Metabolics, ICI, and other companies, where also more and more understanding of the PHA polymer structures came to light, and also the way different copolymer structures and different blending options could also mean totally different plastic-like properties. And we define the current days innovation wave of the new wave of industrialization, which is really focusing a lot on cost and process breakthroughs. So it's not only about the PHA polymer anymore, but it's also about how do we integrate new feedstock strategies that can dramatically lower the cost of production, such as agricultural residues, such as seaweed-based, such as industrial waste streams, and even CO2 conversion into PHA products. And secondly, also a really big focus on making PHA ready for the plastic processing industry, more or less as a drop-in solution, where in the past this was definitely not the case, with a lot of processing issues. You see now a lot of forward integration from PHA manufacturers and compounders to create so-called market-ready drop-in compounds. Sometimes these are blends with PHA and other materials like PLA and PBAT, but more and more we also see full PHA compounds that can directly replace traditional plastics. And of course, also what you see is that more and more of these compounds are becoming commercially available with also the right certification and labeling in place, so that also these type of products can be used in food contact sensitive packaging, in medical packaging, but also has the right end-of-life labeling, such as OK compost, marine biodegradation labeling, and so on. Then I would just like to give a short overview of who are part of this ecosystem in the industry, and then I'll just leave it there. So what we have seen, of course, in the past with the early industrialization is that quite soon people started talking about creating 50 kiloton production plants, and this has proven to be not such an effective strategy. What we see now is that people take a much more careful approach in scaling, and some of the best examples are in the top right corner with the four major industrial players at the moment with more than 10 kilotons of production capacity installed, and also having a variety of market-ready grades with the right certifications in place. And those are NRCan, CJ Bio, and PHA Builder. Interestingly, Danimer Scientific was just acquired by Technor Apex and have basically restarted their entire operation with having kept also a lot of their core personnel to also do that. And what you also see here is a few runners up in the scale up sector. Of course, Paul Boudreau is also on this call here. It's nice to see you from Bosch Bioproducts. And also, one of the scalers from United States that's going to make the next step soon is RWDC Industries. And of course, one other company that you see there is Terra Verde, which is also a Canadian-based company. And then, very interestingly, is of course the left bottom corner with a lot of startup activity. At the moment, we have listed 22 startups that are in the space, and we know that there's many more that are even a little bit earlier. So all of them that you see here, we know and have been validated to work on PHA developments in one of the other way. And I think interestingly is that the innovation space is also very nicely covered here. So not one of these companies is doing the same. And you see here innovations based on feedstocks, innovation based on strains and production routes, innovations on process technology, innovations in application development, and so on. So that's really exciting for the future. And of course, from GoPHA, we would be excited to see, of course, the move to the top right corner of this graph as well. We have a similar graph on application development, where basically you go, of course, from a technical piloting to market validation to commercial scale. And really, PHA is now starting to cover all the plastics applications in one or the other way. So where in the past, PHA was only being used for injection molding, basically, now you see a lot of activity in foams, in thermoplastic elastomers, in bottles with extrusion blow molding, in fibers for textiles and nonwovens. And of course, some of these are a little bit earlier, but we have seen many great samples and technologies come alive already. And then just going to the last slide here about the PHA industry growth is that currently we are here in the middle with total installed capacity of 50 to 100 kilotons globally. And we look forward to scaling that industry to the next level, where is really unknown yet if that's going to end up in the hundreds or in the thousands of kilotons in the next 10 years. So that's exciting to see and to follow. That's it for now. I only have 5 minutes. Of course, we can talk much longer, but I hope to answer a few questions later. Thank you.
Okay, amazing. Thank you, Rick. Okay, I will go back to sharing my screen. Okay, wonderful. So we will now transition to the speakations. A reminder that each speaker will have 5 minutes to provide an overview of their work. And we really hope that these presentations serve as an introduction. And that will really help us set us up for a lively discussion later in the event. As I noted, I'll be sharing my screen for all of the presentations, so there's no need to worry about sharing your screen during your time. I will also be monitoring time. As I mentioned, I will give you a marker when you have 1 minute left in your presentation. So you will see that a 1 minute marker will appear on the top right-hand side of your screen. And at that point, please just try to wrap up your presentation. I will then join you again to transition into our next speaker. So without further ado, our first speaker will be Dr. Minh Tan Tonthat, who is a program leader and team leader for the National Research Council in Canada. Tan, do you want to take it away?
Yes, so thanks, Banis, for your introduction. So very nice to meet all of you today. So I think that Eric only mentioned very well. There's a lot of nice advancement in the PHA production and scaling up. And I think that today I will just provide another angle in terms of how we going to fine tuning the property of the PHA in order to expand them into different applications and unlocking new applications as well. So I think that the PHA, you only know very well about the potential, their properties, their advantages, but they also have a certain limitation in terms of property and performance. So because of this, it's really necessary that in the polymer or the plastic world, usually that we will real often blend them with different other plastic. That's what frequently mentioned about polymer blends. So we often blend at NRC where we're blending POA with many different type of polymers and biomass. And so we're working very closely with industry, so we're not allowed to share with you about the such information. But I think that for the purpose of this um, mini workshop, so I just focus in about using the biomass as a modifier for the PHA. So we work a lot we modify the PHA together with the agriculture and forest biomass. It's including starch, lignin, fiber, and so on. So today I just want to make some of the remark about using the lignin as a forestry biomass can be able to offset the cost for the BHA production at the same time that we be able to inherit the new properties that the BHA alone cannot be able to have. So when they have the patented technology in this area, and so we want to take the lignin powder, the moist lignin powder from the plant, we'll be able to blend them with the PHA and all other type of bio-based plastic, polylactide, the BBS, and PPAC, and so on. And so I mean that in our head, we have a very great capability in terms of uh, making the formulations and doing the processing in order to after the transformation of the plants, I mean the PHA and lignin into the plants, then we have another very great capability and experience in transform them into the final products. You can be able to go through about the injection molding, film blowings, film casting, profile extrusion, and form extrusion and thermoforming. So all of the things that Rick only mentioned, so that we have done all of the work in our lab. So it's very interesting that we're capable to be able to improve the performance and reduce the cost. And in some cases, we can be able to um, facilitate about the volume because that sometimes you can use 10% of the BHA to make the plant, or you can use 90% in the plant. So because of it, you can be able to increase the volume when the capacity of the volume is not really available. So we have to be very creative in the way how we do the research at the same time that we are really very active in terms of working with our industrial partner in order to develop different applications. So that's very much I would like to summarize because I don't have a lot of time. So we're here to do the work. We have all the capability in terms of the lab scale as well as the pilot scale. And so we bring the technology from the technology readiness level from 0 to 5, and that we do a lot of technology transfer in our lab. So I mean that is anything that you're interested in terms of explore further your BHA products in different applications. We're really very happy to collaborate with you. Thank you.
Amazing. Thank you, Tan. And you didn't actually even hit your 4 minute mark. So I didn't even have to give you a warning. So that is much appreciated. Okay. Thank you, Tan. Our next presenter today will be apologies, Joa Souza, who is a technology development lead at PAX Biomaterials in the Netherlands. Joa, the floor is yours.
Thank you. We are from Paxpa Materials in the Netherlands. We are focusing on implementing production of a type of PHA, so that's PHBV, so one of the grades, a copolymer of hydroxybutyrate and hydroxyvalerate. And we do this by using residual feedstocks. So you can think about, for example, more industrial process water, for example, like from a paper mill, or for example, side streams or residual streams from the food industry that are rich in organics, and we can convert these organics into PHA. Our goal as a company is to indeed make the production, to implement production out there. So we are trying to do this first in the Netherlands to let know that the business case works. And then, of course, try to expand from there. But our core activities right now is there. And for that, we are busy basically with making a kind of a hub, production hub here in the north of the Netherlands to produce 6,000 tons of PHA that we named Kaleida, which is our brand name for our PHA, basically, the PHBV. And that we hope to have available in 2028. So how we are different, so there's a lot of companies doing PHA production, also from side streams. We already are at the higher TRL, so we are already working with demonstration plants, producing around 50 kilos per week or more. So we have realized this infrastructure is key for the scale up. So we can really now start to have more application development. And that's also what we are looking for. It's also a lot of people willing to work with this type of new polymers. The type of PHBV we produce, the Kaleida, is new because you can buy this type of PHA in the market today, but it's not the same because it has a lower content of the monomer hydroxyvalerate, and we produce a higher content of hydroxyvalerate, and that makes that our material is very flexible compared to the more crystalline material that exists today. So it's very different and even complementary. So this is something that also it's both a blessing and a curse because of course we have a unique product. On the other hand, there's no other product. We have to do the whole market development and product development from this material. So this is to realize this production plant. I can also say, I wrote this in this slide. So this is not one factory that we are going to make. It's actually 3 factories, and that's important to consider because we have a decentralized PHA biomass production stage and then a centralized extraction stage. So how we are going to make our business is basically partner with companies that have that are the owners of the residual streams for producing the PHA biomass, and we do this already with 2 companies. So one is with a paperboard company called ESCA in the Netherlands. So they produce graphic board, and we are going to use their process water and treat it at the same time and produce PHA. The other one is a company called Loop, and Loop is basically a company that collects a lot of side streams and residual streams from the food industry, which are more concentrated, so you can transport them, and they will transport it to a PHA plant that we are going to build together. And of course, then we will build ourselves a Kaleida extraction plant based on our proprietary green solvent extraction process, in which we will basically produce, in the end, the 6,000 tons of Kaleida. Yeah, that's it. Thank you.
Amazing. Everyone's doing so well for time. I really thought I would be interrupting a lot of people. So thanks so much, Joa. Our next presenter will be Paul Boudreau, who is the CEO of Boss Bioproducts in Canada. Paul, your turn. Paul, I can see that your microphone is not muted, but I can't hear you. Are you here? I think what I'll do is we can move on to the next presenter. And then Paul, if you can hear us, feel free to communicate in the chat if you're having technical difficulties.
Yeah, right now,
you're
is
here.
it okay? Okay.
Yeah.
Sorry.
Yeah, amazing. Okay, you're up. you've muted yourself. Paul, your microphone is muted right now. Are you able to unmute it?
Works?
Yes, you're back.
Okay, I touch nothing yet.
Yeah, don't touch anything. Okay, you're off. Go ahead.
Okay, so thanks for the first presentation, Rick, for the presentation of PHA around the world. It's very important to understand where we are. Also, NRC, you must understand that we have ongoing projects with them for compounds development. They have a very large team of scientists and engineers on polymers. It helps BOSC to become now a compounder and also a finished product producers on PHA-based compounds. Okay, so we move firstly from the PHA production. We have our own technology to produce PHA from non-edible feedstock, but we really move toward the end to go up to the finished product because the value chain in the plastic industry is very difficult to adapt. Very difficult for them to adapt for those new biomaterials. So we decided to go up to the end and offer products that we sell directly to consumers and also to brands. I would say that the most important thing that we discovered in the last year, the big issue with all those components of biomaterials is the price. Okay, we can discuss a lot of things about science, about development, but the problem is to explain what's the value of a PHA-based compound or PHA to compare with very cheap plastic in the industry. So it's very difficult to make that communication and explain why those products are so good, because we do not compare apples with apples. Okay, we have a product that includes the end of life with our offer, but not the plastic, and we have to continuously pitch this comparison to the customers. So I would say the big obstacle right now for PHA development is the market, it's the price. But there are ways to do it. We must communicate well what's the impact, the real impact of plastic compared to the advantages of those biomaterials. So for us, it's where we are putting all our efforts, okay, to develop the market. It's very promising. Now we're jumping in the food, the contact packaging industry. That is very promising, but it's a lot of job to work with customers, to close a deal and start to sell the product. Right now, we're in commercialization for many products. We use all the polymers, all the PHA available to start because it's really an issue to what we discover, each customer, for each product they have, we have to customize the product. So it's a big job to do it, but we must pass through these steps. So it's important also to give to the customers that PHA is not a science a product, it's a commercial product today that could be sold. And it's important to pass this message to the industry. Okay, I think there are, we say, too few opportunities to do it. And I think it would be very important to focus on that aspect also. Last point to stay in my 5 minutes, certification is key also. Okay, if you want to make a difference when you present your product, the industry asks always for certification. It's very expensive and very long, okay, because it's the end product that must be certified for compostability, for food contact application. And we must find a way to simplify and, if possible, to shorten that part of I would say, the most important part to succeed in commercialization. So how to reduce the cost and the time for certification is key for that. Okay, that's it. You can remove the first minute. The 1 minute remaining, I'm okay.
Okay, amazing. Okay, thank you, Paul. We'll move on to So actually, our next presenter, Tim Borner from Switzerland, he did share us the presentation that he had prepared from EMPA, but unfortunately he had an emergency for today and will not be able to join us. So I wanted to just share the presentation that he did share with us. This will be included in the recording. We can also make these slides available, and you are welcome to follow up with Tim offline if you have any questions or if you want to connect with him after today's event. But yeah, unfortunately, he's not able to join us today. We're also, for our next presenter, we're unfortunately not sure if Beth will be able to join us today. So I'm going to move on past Beth's presentation. And if Beth is able to join us later, then we can return to this presentation. So just in case we don't come back, Beth is the executive chair of the Versurance Center, which is based in Canada. And Beth, I'm sure, would be also happy to connect offline. Okay. So our next speaker will be Pranav Kulkarni, who is a senior scientist and business developer at RISE in Sweden. Pranav, go ahead.
Hello, can you hear me?
That sounds great.
Yeah, okay, that's great. So hello everyone, and thanks for organizing this wonderful conference where I'm gathering everyone in the PHA field. Most of them are who are going either for the commercialization or developing technologies. But saying that, I would like to mention that we at RISE from Research Institute of Sweden, here in Nordic region, we are not, let's say, PHA producer or kind of technology provider. But what we do is we do provide our facility, which is, let's say, being a government organization and helping for the bioenergy and biorefinery concepts. We have provided this facility, which is open for all companies and academicians and everyone for testing their technologies at scale. And saying that, I'll say, like, we here have the facility, which is lab scale to pilot scale facility, which is going up to like 10,000 liter fermentation. And personally, I found that, like, previously I was working for an industry called Praj Industries for scaling up, and then here I found that all the facilities very much relevant and capable of taking care of PHA production, including going for the scale on the fermentation upstream side and also on the downstream side. So what we do is basically we help a different kind of industries and companies or startups to develop their technology as they want, and then it will be owned by our customers primarily, all the work and IP, and we will be just, let's say, kind of a CRO or CDMO kind of facility for them. And then what we have is we have all the infrastructure in the upstream with different fermenters at lab scale and pilot scale, which is, as I mentioned, going up to 10 KL facility. And that comes along with the downstream infrastructure of centrifuges, different kind of centrifuges, filter press, homogenizer, and even like belt dryer with a pelletizer attached to it. So we have all this capacity, which is basically can take care of the 10,000 liter fermentation scale of broth, and we can do both upstreaming and downstreaming at a scale. To support this activity, I will say the RISE, which is a wide nation spread organization, and we have a material department which support us in a way to make any kind of composites or maybe forming any kind of prototypes. And then this is basically the pilot infrastructure and packaging material they also have in that particular section of RISE. So it will be, let's say, that can be connected towards it. And then the supports or expertise which we will came, obviously, like everyone needs their own expertise or don't want to give their process or let's say the kind of job to the non-technically expertise. But we have here in our facility, we have different different scientists that are different expertise, including in upstream and downstream, where they have either previously worked here, for example, Abhishek, and who is present in this conference, and me have worked previously for the PHA technologies, and then we can be relevant in that way. And none of this, like we have the strain development department, where if some kind of strain modifications and other things we can help too. I also hear that there are a lot of things around the TA and LCA kind of services, and that we provide around from our innovation services, and that's how we support overall technology development as per the need, and not, let's say, the kind of primary technology provider, but it's, let's say, the technology development service provider. Okay, so that's about RISE and our facility, and we look forward to have a collaboration with multiple partners and maybe help here in the multiple participants. Thank you.
Amazing, thank you. So unless Beth does join us later, our next speaker will be our last. So next up we have Irene Rios, who is a packaging group researcher at AIMPLAS in Spain. Irene, go ahead.
Yes, thank you for the invitation. It's a pleasure to be able to share our innovation with PHA. And for who don't know AIMPLAS, we are a research center based in Paterna in Spain. And yes, I want to tell you some innovations that we are working here in AIMPLAS. So here we have been working for many years on biopolymers, particularly in that case with PHA, covering the entire value chains from the synthesis to the market. So we go from obtaining them through biotechnological fermentation processes using, for example, waste, but also we can work with commercial grades, to their transformation and processing into real applications. So we have developed different methodologies that allows us to cover and valorize wastes to produce these biopolymers, and also modify them by compounding a process using twin screw extruders and adding some different additives to increase or to improve the mechanical properties, or to meet the necessary requirements for different uses, especially in my case, in the packaging sector, but also we work in the agricultural sector too. What more? We have a strong expertise in processing technologies, not only in compounding, where we have different pilot plant extruders, but also doing some extrusion and injection molding, and also coatings with this PHA. Which enables us to transform this PHA into both rigid and flexible packaging. That it depends on the final end user that we work directly with them, or in some innovation or, for example, European projects. So at the end, this comprehensive approach places us at a technology readiness level ranging like a tier L between 3 and 6, because we have a lab scale equipments. For example, we can work from 200 grams, but also we have a pilot plant equipments to produce 30 kilos per hour by compounding, or to like a final validations before to the end user at an industrial level. But it's true that in our case, we only achieve a tier level of 6, but we can up to tier TRL8 with in collaboration with industrial partners. So in that case, what we look for is to open the door, the commercial door to commercial applications in sustainable packaging and beyond. So this is our work. So as I said, we covered all the value chains from the biotechnology part to change. So if, for example, the DG of the raw material at the beginning, and then to transform it by different process technologies like compounding, extrusion, injection, or coatings. And also we can validate the biodegradability and compostability. And that's all. Thank you.
Okay, thank you so much, Irene. So with that, I will stop sharing my screen. And I want to just thank all of our speakers for taking the time to, prepare for today's discussion, provide such a nice high-level overview of the work that you do. This will conclude the recorded portion of today's event. We want to thank any viewers who may be viewing this recording at a later date, and we'll remind everyone that we will prepare a final report that we will make publicly available in addition to this recording, and we will share a high-level overview of the discussion that will follow the recorded portion of this event. So thank you to our online viewers in the future, we can conclude the recorded portion now. Jan.
The Assurance Center is just a scale-up center. That's what we call it. It's not an incubator or an accelerator. We've built like physical plant for a client base to actually scale in, and we go from what we call TRL 4 to 5 up to commercial scale. So we particularly focused on precision fermentation as a way to generate bio-based polymers. In support of that, we have a whole load of lab assets that will allow us to do polymer testing, particularly in the focus area of functional films. And to that end, we have all of the tensile strength, oxygen barrier type testing, crystalline structure to support what particular plastics our clients are making. Obviously, our focus with precision fermentation would be PHA, PHB, PLA, all of those pieces, but produced by microbes. And so for that, we've built 100 and 1,000 liter fermentation capacity in our pilot, and we partnered on the other end. In the picture you can see here is large scale 100 cubic meters for our European partners. Fermentation plus the downstream. And I just caught the end of the previous presenter on some of those downstream pieces, which, extracting your value molecule after fermentation is always the key. And in between, we just built a demonstration plant that's 10,000 liters capacity. So we have SME clients, as I said, that come in, they keep their IP while they scale. They use our assets. We're a service-based business, and that's how we grow them. So I'll leave it at that.